Electric current is defined as the rate of flow of electric charge through any section of wire. I equal to dq upon dt. SI unit is ampere. It is a scalar quantity. The direction of flow of positive charge gives the direction of electric current. Electron flow opposite to it. It is of three types: steady direct current, variable direct current, and alternating current. Current carriers are electron in solids, free electrons and holes in semiconductors, positive and negative ions in liquids, and ions and electron in gases. At room temperature, free electron move randomly inside conductor due to thermal energy, so net flow of charge and net electric current is zero. When external electric field is applied, electrons start drifting toward positive end of the conductor. Due to this acceleration, they gain an extra velocity called drift velocity for short interval of time called relaxation time. They collide with other ions and electrons in their path and lose the extra velocity, hence the energy, and again start drifting toward the positive end of the conductor. Average drift velocity depend upon charge and mass of electron, electric field, and relaxation time. Current is equal to NAVD time E, where N is number of electron per unit volume, A is the area of the conductor, E is the electronic charge, and VD is the drift velocity. The ratio of drift velocity to external electric field is called mobility. The amount of current passing per unit area of the conductor held perpendicular to flow of charge is called current density. According to Ohm's law, current flowing through a conductor is directly proportional to potential difference applied across the conductor. V is equal to IR, where R is the resistance of the conductor. It is the opposition to the flow of the current by the conductor. SI units of resistance is ohm. Ohm is equal to volt per ampere. Resistance is equal to rho L upon A, where L is length, A is the area, and rho is the resistivity of the conductor. Resistivity is the specific resistance of the conductor of length and area 1 unit. Its units are ohm meter. Reciprocal of resistance is called conductance, and reciprocal of resistivity is called conductivity. Ohm law can be derived using concept of drift velocity also. Resistance depend upon the nature, temperature, and dimensions of the conductor, whereas resistivity depend upon nature and temperature of the conductor only. In microscopic form, ohm law is given by current density is equal to conductivity times electric field. For small conductor, metal obeys Ohm's law, but with increase in temperature, the resistance also increases, therefore heat is produced and Ohm's law is not followed. Ohm's law is also not followed by semiconductor diodes and compound semiconductors and thyristors. With increase in temperature, the resistance of the metals increases. Variation of resistance with temperature is very small for alloys, and for semiconductor the resistance decreases with increase in temperature. Resistance increases in series and decreases in parallel combination. There are some numericals. Total amount of work done by a source to maintain a current in an electric circuit is known as electric energy. E is equal to VIT in form of heat. H is equal to I square RT. Its practical units are kilowatt hour. Electric power is defined as the rate of dissipation of heat energy by the conductor. P is equal to VI or IR square. A device which provides potential difference across the circuit for flow of current is called cell. The potential difference between two terminals of the cell when no current flow through it is called EMF of the cell. The opposition offered by the electrolyte of the cell when current is flowing through it is known as internal resistance of the cell. It depends upon nature of electrolyte and area and distance between the plates. The potential difference between two terminals of the cell when current is drawn through it is known as terminal potential difference. Internal resistance of the cell is equal to E upon B minus 1 into capital R, where E is EMF, V is terminal potential difference, and R is external resistance. To get a large current, different cells are connected in series when external resistance is very high as compared to internal resistance of the cell. Different cells are connected in parallel to get large current when the internal resistance of the cell is greater than the external resistance. If internal resistance is equal to external resistance, then cells are connected in mixed grouping. Kirchhoff's first rule, also called junction rule, states that the algebraic sum of all the currents meeting at a point in a circuit is zero. Kirchhoff's second rule, also called loop rule, states that in a loop the algebraic sum of all the voltages is zero. That is, the potential across all the elements is equal to EMF of all sources. An arrangement of four resistance used to measure unknown resistance in terms of other three resistances is called Wheatstone bridge. It is based on the principle that value of R is so adjusted that galvanometer gives no deflection. At this situation, P upon Q is equal to R upon X, where P and Q are called ratio arm, X is unknown resistance, and R is variable resistance. Some important numericals.